So now we're going to talk about a process called the central limit theorem. If we know the distribution of some population and its mean and its standard deviation, so if we know the actual mean and standard deviation value, and then we collect a sample of all possible sample sizes of size n and calculate each of these samples, the distribution of the means of those samples will of size n will take on the shape of a normal distribution if the population is bell-shaped or if the sample size is big enough. So we're going to put normal distribution here. This is what I talked about in the last video. Let me scroll up and take a look. Remember when we were finding the average of means? Again, I might get some really small, or I might get a really high average, I might get a really low average, but eventually those averages are going to build up into a normal distribution. So if the original population has a normal distribution, then the big enough in terms of the sample size can just be 1. But if the original population does not have a normal distribution, then the sample size must be at least 30. The means of samples, the means of sample means distribution is, we use, it looks like the mu, but we put a little x bar to the right of it because what we're going to symbolize is this is the average of all of those averages. The standard deviation, though, we're going to need to change this. So what you see here is the standard deviation is whatever the standard deviation of the population is divided by the square root of the sample size. We're going to see some example of this in a second, but basically when you're averaging a bunch of people up, the distribution is going to be a lot more narrow. You're going to have a smaller distribution. We're going to see this in a second. So here's an example. In the United States, men's heights have a mean of 69.2 and a standard deviation of 3 inches. It's also known that males' heights in the United States is normally distributed. First, we're going to look at the probability that if we select one male from the U.S. population and that their height is between 66 and 71. So below is a graph. Let's shade this probability. I cannot see this very well, so I'm going to need to make this a little bit bigger. Hold on a second. All right, sorry about that. I needed to be able to see those numbers. So 66 and 71. So we're going to shade between 66 and 71. And it's a good amount of this distribution, but we're looking for this probability or this area right here, correct? Okay, so now using the Excel file, we're going to find the probability that if we select one male from the U.S. population that their height is between 66 and 71. So if you can fit it, you can fill it in there, but we're finding probability that a value is between 66 and 71. So we actually did this in section 6.3. We're going to go to our Excel spreadsheet. We're going to use not the left or right distribution, but the in-between. So we are in between 66 and 71 with a mean of, it tells me my mean up in the top of the problem is 69.2, and our standard deviation is 3. So what is the probability that I select somebody? 0.5827. So this is 0.5827. Now, what is the probability that if I randomly choose 16 males and I average their height up, that their average will be between 66 and 71? And this says, do you think that this probability is going to go up or down? Just take a guess. Just write it right here. Sometimes it's nice to just think about this and just, if you don't know, just give it a guess, okay? So now what we're going to do is we are going to work on this in terms of this distribution right here. So it says we're going to pick 16 males, right? So using the information discussed in the previous, at the top of the video, we need to adjust the standard deviation since we're averaging a bunch of males' heights up. So the mean is still going to be 69.2, but since I am doing a sample of 16 people, we're going to alter that standard deviation by taking the old standard deviation and dividing it by the square root of our sample size. How many people are in my sample? There are 16 of them. So it's going to be 3 divided by the square root of 16. So I can do that in my calculator. I also could probably work it out in my head, but if you're working at 3 divided by the square root of 16, and we get 0.75. So you can see my old standard deviation was 3. My new standard deviation is 0.75. I have made that standard deviation much smaller because, again, we are averaging a bunch of males' heights up, so we're not going to have as many outliers, because even if I do pick a very tall person, they're going to wash out in the long run. So what is between 66 and 71? That is, I can't even shade 66, so it's everything to the left, and then all this stuff right here, right? It's everything in between these two values. So we are going to still pick the in-between tab because there might be some values that are even further to the right of that. But this is what we're shading. So let's find this probability. So I'm going to again pick the in-between tab. We're between 66 and 71. The average of 16 males is still the average of one male in the long run. So that stays 69.2. But we change this to 0.75. And we get 0.9918. So it's a lot more likely that if you average 16 males up, that their average is going to be between these two values. So I think we got 99.8%. So probability that X is between 66 and 71 is 99, what did I say, 99.8%? 99.18%. All right, in the next video we're going to look at some more applications and when we're going to use the sampling means and when we would use the individual distribution.